Hello, today we're going to learn about writing inequalities. So our objective is to write and graph inequalities, and this is page 45. All right, well, first of all, an inequality is a mathematical sentence that shows the relationship between quantities that are not equal. So one could be more than the other or less than the other, but they're not going to be equal. All right, and then a solution of an inequality is a value that makes the inequality true. So for example, right here I have t is less than 5. So a solution would be something I could plug in for t and it be less than 5. So one example of a solution is 4. 4 is less than 5. Now just like with expressions, inequalities can have many solutions. So I could plug in a 3 here. 3 is less than 5. 1 is less than 5. Negative 5 is less than 5. All right, so then how to graph this? Well, first of all, I'm going to just go ahead and put 5 in the middle. Here's 5, so this would be 6, 7, 8, 9, 10, and so forth. And count backwards, 4, 3, 2, 1, 0, negative 1. Now, can I actually plug a 5 in for t? Well, 5 is not less than 5. So I can't plug in a 5, but I can plug anything smaller than 5. So what I do is I put an open circle like this, which means that 5 is not a solution, but then I put an arrow going this way to the left because all of these are less than 5. So anything along this arrow could be a solution, but 5 is not going to be. That's why it's open and not filled in, okay? So all of these also would not be solutions because these are not less than 5. So 5 is not less than 5. Anything greater is not less than 5. Anything to the left, however, would be a solution. Even 4.999999999 would still be a solution because it's less than 5. Okay? So first of all, we need to learn these key phrases and the symbols and make sure we're able to recognize them. So right here we have the less than sign. Now, a few other phrases that you might see in a word problem could be fewer than or below. Okay, next we have the greater than sign, and some key phrases would be more than or above. And for both of these, because they don't actually include the number that's less than or greater than, we have an open circle. So we're going to put an open circle like this and an open circle right here. And let's label that open. So when you have open circles, it doesn't actually include the value that it's laying on top of. All right, and then right here, we have the less than or equal to sign, which some other phrases that mean the same thing would be at most, no more than, and maximum. And then we have the greater than or equal to sign, which other key phrases could be at least, no less than, and minimum. Now with both of these, you have a closed point. So we're going to put a spot and fill it in. And then write closed. And by closed, that means that this can actually be the solution because it has the equal line also. So if it says less than or equal to, it can be that number and smaller. If it says greater than or equal to, it can be that number and greater. So let's look at some examples, then I think it will make more sense. All right, so right here I have y is less than or equal to negative 3. So I'm going to start by just putting negative 3 on my graph. So then if I think, remember the negatives, they count backwards. So going this way would be negative 4, negative 5, and then going this way would be negative 2, negative 1. All right, so I look right here and I see that I have the equal line, which means it can be negative 3 and it can be less than negative 3. So I look right here, less than or equal to, it's a closed dot. So instead of putting an open one like that, like we did here, I'm actually going to fill it in because negative 3 is a solution. Here, 5 was not a solution, that's why it's open. Here, negative 3 can be a solution. It's also anything less than negative 3, so that would be this way. All right, and notice, look the way that my inequality sign is pointing. It looks like an arrow. It's pointing to the left. So then my arrow that I draw when I graph it is also pointing to the left. Now remember, this only works if your variable is first. So if you have the variable and then your sign and then your number, then you can just look the way that the arrow or the inequality sign is pointing, and you can make your arrow point the same way. Okay, so now let's look at the next one. So is the variable first here? No, so we have to be careful. I know it says 1 is less than m, but I want to rewrite this so that the variable is first. All right, so when I rewrite it, then I need to make sure that the m comes first, and since it's open towards m, I need to make sure it's still open towards m when I rewrite it, so that I'm not actually changing what the inequality says. And then the 1 was here, so I put the 1 here. So it looks like I've flipped the inequality sign, but really I've kept it meaning the same thing. It's just because I moved the position of the 1 and the m that I had to also make sure this changed as well. All right, so now it says m is greater than 1, which means the same as 1 is less than m. So here I'm going to put a 1. So here could be 2, 3, and on this side would be 0 and -1. All right, and now I look here, it's a greater than sign, and I look right here, and it's an open circle. So I need to put an open circle. And then it's pointing to the right, so I'm going to make it my arrow go towards the right. All right, and so this open circle right here means that 1 itself is not a solution. Okay, right here, -3 was a solution because it's closed. Right here, 1 is not a solution because 1 is not greater than 1. But anything to the right of 1 would be greater. 1.1 would be greater. That would be a possible solution. 2 could be a solution. 3 could be a solution. Anything along this arrow. 2.5 could be a solution. All right, so now let's look at a little situation here. We're going to pick out these key phrases to help us figure out what the inequality sign is, and then we're going to graph them. All right, so we have the temperature in a walk-in freezer must stay below 20 degrees Fahrenheit. So I look here, here's below, and it's the less than symbol. So there's less than, and it says below 20, so less than 20. And it says the temperature in a walk-in freezer. Well, I don't know the temperature in the walk-in freezer, so that's my variable. So we're just going to call it T for temperature. So this is saying T is less than 20. So then when I graph this, here's 20. So this way would be 21. This way would be 19. All right, now I look here, it's an open because it doesn't have the equal line. That's how you remember the equal line lets you know it's closed. Okay, so there's no equal line, so it's going to be an open circle. And the variable's first, so I just look the way the inequality sign's pointing, and it's pointing to the left because all of these are less than 20, and it says T is less than 20. All right, now let's look at the next one. C is less than 1.2. All right, so we've got C. We've got less than, which is right here. And then 1.2, 1.2. All right, so when I graph this, I'm going to just put 1.2 in the middle. Maybe 1.3 we could put next, count by tenths. 1.1 we could put here. It's an open circle because there's no equal line. So open, it's pointing to the left. My variable's first, so I can look the way it's pointing to the left. So I can put my arrow this way. And there you have it. Okay, last one. Y is greater than or equal to 5 halves. So Y greater than or equal to looks like this. And then 5 halves. Now, you could change that to a decimal if you wanted, or you could keep it as a fraction. We'll keep it as a fraction for now. So 5 halves. Well, after that would be 6 halves, which is the same as 3. And before that would be 4 halves, which is the same as 2. So this is basically 2.5. Now, I see the equal line, so it's greater than or equal to, so it's going to be closed circle, meaning 5 halves is a solution. And it's Y is greater, so anything greater is also a solution, or you can look, it's pointing to the right. So So it's going to go to the right. All right, so we could have 3 as a solution. We could have 100 as a solution. We could have 1,000,000 as a solution. As long as it's to the right, 5 halves or greater. All right, well, that's how you graph inequalities. Thanks for watching.